Hi everybody. In this lesson we want to look at variation. Now variation has to do with how one variable responds when another variable changes. So here's an example of direct variation. Consider a car that's traveling 60 miles per hour. As the time variable goes up, as time increases, the distance is also going to go up. Alright, it's going to increase as well. We say then that the distance varies directly to the time, or that the distance is directly proportional to the time. Symbolically, there's a little symbol for proportionality. Looks like this. We would say that the distance is proportional to the time, and that means that there is a constant k that we call the constant of proportionality, such that the distance is equal to k times t. So you don't necessarily have to use this symbol right here because it always means equals k times, but sometimes it's helpful to just translate the language directly into this and then go ahead and write it as equals k times. So in this case the constant of proportionality would be the speed of the car. Alright, now here's another example of inverse variation. If you think about the volume of gas in a sealed container, like a plug syringe, maybe you played with those as a kid and you'd fill them with water and stuff, but if you just have air in it and you put your finger over the end, hopefully without the needle on it, and then you push down on the plunger, well, as the pressure goes up, the volume inside of that sealed syringe is going to go down. So as the pressure variable goes one direction, the volume variable is going to go in the other direction. Okay, so in this case we'd say that the volume varies inversely to the pressure, or that the volume is inversely proportional to the pressure. Alright, so what we mean by inverse is a multiplicative inverse, and the volume then would be squiggle or proportional to the inverse of the pressure. And we would say this: the volume is inversely proportional to the pressure. And again, that means that there's a constant that I can replace that proportionality with equals k times. All right, so inverse proportionality or an inverse relationship means that one variable is equal to a constant times 1 over the other variable. Direct variation means that the one variable is equal to a constant times the other variable, not 1 over the variable. Okay, so here's an example of the proportionality. From earliest times it was recognized that the circumference of a circle varies directly as the diameter. So that means that the circumference is directly proportional to the diameter. As the diameter gets bigger, the circumference gets bigger. And so that means the circumference has to equal some constant times that diameter. Alright, so by very careful measurement using like a string and a coffee can of diameter 7 inches, it's found that the circumference, if the coffee can has a diameter of 7 inches, the circumference is right around 22 inches. And you can verify this. You take various cans and just stretch a string around it, and then take the string and measure it, and you will find then that since the circumference is equal to some constant times the diameter, in this case the circumference of 22 inches is equal to k times the diameter of 7 inches. So that now means that the constant is 22/7. Okay, so in this case those are just approximate values. We now know that the constant of proportionality is more precisely known as pi, and that's only approximately equal to 22/7. It's an irrational number, 3.14159, which isn't exactly 22/7. But anyway, once you know that constant is about that number, then forevermore you can say that the circumference is going to be pi times that diameter, right, or approximately 22/7 times that diameter. So then, rather than having to use a string to figure out what the circumference is, it's much easier to use a ruler and just measure the diameter and then multiply it by 22/7, and then you'll get the circumference much more easily. And so now we have this relationship, and we would call this the equation of variation. All right, and then this up here, that would be the constant of proportionality. Okay, all right. So let's do one last example here, just to put this in context. If I say that y varies inversely as x, then that means y is squiggle to 1 over x, which means that there is a constant k that makes y equal k times 1 over x. Now they give me some information here that y is equal to 8 when x is 2. Well, that means that I'm going to be able to figure out what k is, right? So if y is 8 when x is 2, I can just go ahead and multiply both sides of this by 2, and I'll get that my k value is equal to 16. All right, so this is my constant of proportionality, and that will stay the same, just like pi did up here. That's never going to change, at least for the particular circumstances there. And then once I have that, I can write the equation of variation for this relationship, because all I have to do is just take this k value, right, and then plug it back in over here. So I know that y equals 16 times 1 over x. This would be my equation of variation. And now once I have that equation of variation, then I can answer any questions. I could say, well, if x is 4, what's y going to be? Well, that's easy. It's just going to be 16/4 or 4. Or if x is 8, then I know that y is going to be 2, because this equation of variation will now work for all values of x and y.